Metaprocess modeling. Metaprocess modeling is a type of metamodeling used in software engineering and systems engineering for the analysis and construction of models applicable and useful to some predefined problems. Metaprocess modeling supports the effort of creating flexible process models. The purpose of process models is to document and communicate processes and to enhance the reuse of processes. Thus, processes can be better taught and executed. Results of using metaprocess models are an increased productivity of process engineers and an improved quality of the models they produce. Overview. Metaprocess modeling focuses on and supports the process of constructing process models. Its main concern is to improve process models and to make them evolve, which in turn will support the development of systems. This is important due to the fact that processes change with time, and so do the process models underlying them. Thus, new processes and models may have to be built and existing ones improved. The focus has been to increase the level of formality of process models in order to make possible their enactment in process-centered software environments. A process meta-model is a meta-model, a description at the type level of a process model. A process model is thus an instantiation of a process meta-model. There exist standards for several domains: software engineering, software process engineering meta-model SPEM, which is defined as a profile UML by the Object Management Group. Topics in metadata modeling. There are different techniques for constructing process models. Construction techniques used in the information systems area have developed independently of those in software engineering. In information systems, construction techniques exploit the notion of a meta-model, and the two principal techniques used are those of instantiation and assembly. In software engineering, the main construction technique used today is language-based. However, early technique ad hoc. Traditional process models are expressions of the experiences of their developers. Since this experience is not formalized and is consequently not available as a fund of knowledge, it can be said that these process models are the result of an ad hoc construction technique. This has two major consequences. It is not possible to know how these process models were generated. Assembly. The assembly technique is based on the idea of a process repository from which process components can be selected. Rowland 1998 lists two selection strategies: promoting a global analysis of the project on hand based on contingency criteria, example Van Slooten 1996, using the notion of descriptors as a means to describe process chunks. This eases the retrieval of components meeting the requirements of the user / matching with the situation at hand. Example Plehan 1995, in Nature, and repository of scenario-based approaches accessible on Internet. In the Cruise project, for the assembly technique to be successful, it is necessary that process models are modular. If the assembly technique is combined with the instantiation technique, then the meta-model must itself be modular. Instantiation. For reusing processes, a metaprocess model identifies the common, generic features of process models and represents them in a system of concepts. Such a representation has the potential to generate all process models that share these features. This potential is realized when a generation technique is defined whose application results in the desired process model. Rowland associates a number of advantages with the instantiation approach. The exploitation of the meta-model helps to define a wide range of process models. It makes the activity of defining process models systematic and versatile. It forces to look for and introduce, in the process meta-model, generic solutions to problems, and this makes the derived process models inherit the solution characteristics. The instantiation technique has been used, for example, in Nature, Rowland 1993, Rowland 1994, and Rowland 1996. The process engineer must define the instances of contexts and relationships that comprise the process model of interest. Language. Rowland 1998 lists numerous languages for expressing process models used by the software engineering community. 3. Various Prolog dialects for EPOS, OCOs, and PIS. PS Algol for PWI as well as further computational paradigms. Petri nets in EPOS and SPADE. Rule-based paradigm in Merlin. ALF. Marvel. EPOS. Triggers in ADEL and MVPL languages are typically related to process programs, whereas instantiation techniques have been used to construct process scripts. Tool support. The meta-modeling process is often supported through software tools called CAME tools, computer-aided method engineering, or meta-case tools, meta-level computer-assisted software engineering tools. Often the instantiation technique has been utilized to build the repository of computer-aided method engineering environments. Example tools for meta-process modeling are Maestro Roman 2, Min2, MetaEdit Plus, Mentor. Example, multi-model view. Collett Rowland 1999 provides an example of a meta-process model which utilizes the instantiation and assembly technique. In the paper, the approach is called multi-model view and was applied on the Cruz-Electroir method. The Cruz-Electroir method represents a methodical approach for requirements engineering, the part of the IS development that involves investigating problems and requirements of the user's community and developing a specification of the future system, the so-called conceptual schema. Besides the Cruz-Electroir approach, the multi-model view has served as a basis for representing the three other requirements engineering approaches developed within the Cruz project: real-world scenes approach, SAVR approach for scenario exceptions discovery, and the scenario animation approach, for integrating approaches one with the other and with the US approach. Furthermore, the Cruz-Electroir utilizes process models and meta-process models in order to achieve flexibility for the situation at hand. The approach is based on the notion of a labeled graph of intentions and strategies called a map. Together, map process model and the guidelines form the method. The main source of this explanation is the elaboration of Rowland. Process model/map. The map is a navigational structure which supports the dynamic selection of the intention to be achieved next and the appropriate strategy to achieve it. It is a process model in which a non-deterministic ordering of intentions and strategies has been included. It is a label-directed graph with intentions as nodes and strategies as edges between intentions. The directed nature of the graph. The map consists of goals/intentions marked with ovals which are connected by strategies symbolized through arrows. An intention is a goal, an objective that the application engineer has in mind at a given point of time. A strategy is an approach, a manner to achieve an intention. The connection of two goals with a strategy is also called section. A map allows the application engineer to determine a path from start intention to stop intention. The map contains a finite number of paths, each of them prescribing a way to develop the product, i.e., each of them is a process model, therefore the map is a multi-model. Guidelines. Meta-process map. Sample process. The sample process eliciting requirements of a recycling machine is about a method for designing the requirements of recycling facilities. The recycling facilities are meant for customers of a supermarket. The adequate method is obtained through instantiation of the meta-process model on the process model. The following table displays the stepwise trace of the process to elicit requirements for the recycling machine from